Hello everyone, you are welcome to today's robot design class. I am Messia Shabia Mufa, and our main topic for the day is exploring features of selected modeling, programming and simulation tools used for robot design. So by the end of today's lesson, you should be able to explain modeling tools, then explain programming tools, also explain simulation tools, then also identify common robot design software, and lastly explain why these tools matters. Alright, so let's do this quick exercise. So let's all imagine that you want to build a robot that helps an elderly person carry food from the market. So let's take a look at these two options. Option A, which says build it immediately, and option B, which says design and test on the computer. So learners, which of these options are you going to choose? So think about it. Alright, let's look at the correct response. So the correct response is the option B, which is design and test on the computer. Now let's talk about robot design. So robot design is the process of planning, creating, testing, and improving a robot before building the real one. So these are processes, or we will say it's a cycle of thinking, making, and refining. So before you do the robot design, you first develop an idea. Next, you design. Then you write a program to control the robot. Then also you test the robot behavior using simulation tools. Then again, you also finally build the actual robots. Now let's talk about robot design tools. So robot design tools are computer applications that helps engineers design, program, test and improve robots. So robot design tools are going to help you design the robot. You write programs, you test the behavior of the program, then again you can improve the performance, meaning refining and optimizing the robot before even building the actual thing. Now let's move to the three types of robot design tools. So you talk about the first category, which is the modeling tools. Then we also talk about programming tools. Then lastly, simulation tools. So we are going to take these categories one after the other. Then we see how it works. So we will start with the modeling tools. Modeling tools are software applications used to create a digital 3D model of a robot. Some popular examples are Tinkercad, Fusion 360, SolidWorks, and BrickLink Studio. So we have some key features of these modeling tools. One is 3D design and visualization, then virtual prototyping. So as you can see here, this is an interface of Tinkercad. So you see a digital 3D model here. This is a 3D model here. Alright. So in the course of this class, we will explore more into these tools. Now, let's talk about the programming tools. So, programming tools let engineers write the instruction that controls a robot behavior. Some programming tools are Arduino IDE, Lego Spark app, Ev3 Classroom, and Visual Studio Code. It also has some key features, which is code editor with syntax highlighting and error checking and debugging also. Then we have the uploading of code to the robot, which is also one of the features. I know you might heard the term IDE, which is the Integrated Development Environment. So IDE is a single software application that combines everything a programmer needs to write, test and fix a robot program. So IDE helps the engineer write code. It helps the engineer edit code, then again find errors, also upload programs, then test programs too. So IDE helps in all this. So it serves as a multi-functional purpose for engineers so that it makes their works easy and faster. Now let's move to the simulation tools. Simulation tools let engineers test robots in a virtual environment. Popular examples are Gazebo, then Webbot. Then we also have the virtual robotic toolkit. Now let's take a look at why these simulation tools matters, or reason why we need to simulate first. 1. Save money. Then 2. Prevent damage. 3. Save time. 4. Find mistakes early. Then 5. Improve performance of the robot. Okay, so Tinkercad, as we said earlier, is one of the robot design tools. So Tinkercad is a free browser-based tool for designing robot and electronic circuits. No installation needed, just open it in a web browser and start creating what you want to do. So key features of the Tinkercad are easy drag and drop interface, 3D modeling for robot parts, Arduino circuit simulation. Then again, it's also great for beginners. Alright, so as you can see, this is the interface of the Tinkercad. So as we saw earlier, there's also a 3D modeling here. Okay, now let's talk about the Arduino IDE. So the Arduino IDE is the good software for programming Arduino boards. It's the brain behind many beginner robots. So it helps these beginners write their code, check it for error, and also upload the codes directly to the robot. Some key features of this Arduino IDE is write and edit programs, verify code before uploading, then upload code to Arduino board, then also monitor serial output in real time. Alright class, let's do this quick activity. So you are going to match the two. So think about each task below. Which software tool would you use? Discuss with a partner before revealing the answers. So first is design a robot. Which software are you going to use? So write it down. Second is write robot code. Which software are you going to also use? Write it down. Then test robot movements. Write that one also down. Okay, good job, student. Now let's look at what we have been able to discover in this lesson. So in today's lesson, we have come to know that robot design starts with planning. So you don't just start to build the robot immediately. So first of all, you come up with the idea, you do the design, then you program it, then you simulate it, then finally you do the actual robots. Finally you build the actual robot. Then we have also learned about these three categories of robot design tools, which are the modeling tools used to create digital versions of the robot, the programming tools used to write the robot instruction, and the simulation tools used to test robots safely and cheaply. So we will end our lesson here. All right, good job, students. So thank you, great job today. All right, then bye. We will meet next week to continue our lesson.